So I'm going to talk about how I did this question. There's no point in the solution me just saying, "Oh, you should do this," because the whole point of these kind of questions is how you play around with them, try things out, and somehow realize to do what we need to, which is essentially a transformation at the end of the day. But I'll get to that. So the first thing I did is I decided to label um, A, B, C, D, E, F, G, H, I, the circles. It seems a good shout. I mean, this is quite a general proof we're being asked to do. So, but I thought, let's at least start with that and write down some, equations. So we know that A plus B plus C plus D must equal this total, if it's possible to get. And then similar along the bottom row, D plus E plus F plus G is equal to T. And then also A plus I plus H plus G is equal to T. And I thought, I wonder if I can, add these together, combine them, add them all together. Well, we've got 2A, but then we've got B and C and D once and so on. Which other ones? Oh, sorry, D is twice, and then F, 2G. Okay, so that would equal 3T. And these are just possible things that you might have played around with as well. And actually, we've then got A plus B plus C plus D plus E plus F plus G plus H plus I, but we've got an extra A plus D plus G left over. But these are going to add to the sum of all the numbers. And because it's 1 to 9, then we just need to add the numbers from 1 to 9. And that can be done quite quickly, either just slowly by doing 1 plus 2 plus 3, or by remembering the triangle numbers formula. It's a half times 9 times 10. Half n plus 1. Worth looking into that if you are not aware of that. So it's going to be A plus D plus G plus 45 is equal to 3t. And therefore, we could write that A plus D, it must be that this is 3 times t minus 15. So this is quite useful because it tells us that A, D, and G must sum to a multiple of 3. I personally didn't do anything with it apart from that, actually. Um, but it's quite nice to see in this case here, we've got 3, 5, and 7. They add to 15, which is a multiple of 3. So any future ones we might find ourselves, if we're just trying numbers out, we should use that condition because you're not going to get there if you use 1, 9, and 6, for example. No chance. It has to be a multiple of 3. Now, I actually then played around with things a little bit more I'm not going to write this down, but I said, for example, that B plus C plus D must equal I plus H plus G, kind of like combining the simultaneous equations. But the thing is, I'm not going to be able, I realized after writing some of these down, I'm not going to be able to write down like specific conditions relating B and I, probably, because, they don't necessarily, like we could swap these two around, for example, without messing anything up. So, that's enough evidence really to see that we're not going to be able to link like these two together, for example. The proof is like the question is a lot more general. So at this point, I thought, you know what, I'm just gonna try some numbers, just see what else I can make. Use it. I've got my condition to help me. So, for example, we could just go with a 6 in the corners, 1, 3, and 2, and see if that will work. I mean, it doesn't, like this condition, I don't think guarantees it will work, but we can soon find out. So at the moment, I've got my 45 in total, and I'm going to need to minus 6 to give me 39. That's going to be what the rest add up to. And then because actually these two will add to 4, these two will add to 5, and these two will add to 3, I can actually quickly see how I can split the 39 up into 12, 13, and 14 and distribute them appropriately, but like so they can all add to 17 essentially. So I can get a total of 17, but let's just finish it off and get that. So I need to make up and get 14 here. So for example, I could put 9 and 5 here. And then how can I get, I want 12 down here. I could go with 8 and 4, which leaves me with 6 and 7 for 13. Okay, then that will work. That will give me um, my triangle. I haven't like put all the rings around it. Okay, it's not yeah, it's not perfect. It's not all straight and everything, but like, you get the idea. Okay, so t equals 17 is possible. So then I thought, how can we get t equals 23? What sort of change can we make? And I thought, all right, what if I replace 1 by 4? I tried to increase them well, not them by 3, but this I could actually, let me tell you what I did. No, I didn't. I um I tried to replace some of them, but then I realized it wasn't quite going to work. And then it hit me actually. This is the point at which I thought, okay, I think I'm going to try something out. And this is the main bit in the question. It's hard to, you either kind of realize this or you don't, I suppose. It comes from playing around with it. And one thing you might have done is to be able to get, you might have found t equals 23 and then compared like the numbers and seen what is happening. And actually, this is what you need to do. We need to replace each number x by 10 minus x. I actually did 9 minus x to start with, and I realized my mistake. But 10 minus x. So for example, 1 will go to 9, and 9 will go to 1. There's a simple transformation between all of them. 2 will go to 8, and 8 will go to 2. So basically our first grid, this grid here, let me call it star becomes, it's going to be 10 minus a at the top, and then I'm working down, it's going to be 10 minus b, 10 minus c, 10 minus d, and then going along. Okay, and then we're going to get, if we add up the left-hand row, we're going to get 40 minus, I'm going to do this quickly now. I'm going to do like 10 plus 10 plus 10 plus 10 minus a minus b minus c minus d. But that can be rewritten as 40 minus a plus b plus c plus d, which will equal 40 minus t. Hey, and at this point, we can be very happy. We just need to show that it works for the rest of them. 40 minus a, oh, sorry, I'm doing the right-hand one next. Oh well. This will also be 40 minus t. I'm just substituting in t for these up here, which I had right at the top in blue. Okay, so I think that's good to show, just all that working. So if t is possible, then 40 minus t is possible. I feel that's convincing enough. Just to illustrate it, I guess it would be quite good to apply it to this one here to show that we can get 23. So I would replace 1 by 9, 9 by 1, 5 by 5 actually. Stay as it is, that would be 8, 6, 2, 7, 3, 4. And you can see, look, I've got 23 along all of them. So it works really well. So the other way you might have done it would be to get this yourself just by playing around with some numbers, and then see, like, you might not be, you might have swapped these two around, for example, but somehow seen that that is the relationship between them. so that's my main explanation for this question. I've shown how I started, what I wrote down, something that wasn't particularly useful, but I will come back to this in a minute actually. And then writing down a different possibility and somehow like realizing, I suppose at the end of the day, we are proving a very general result, not a specific relationship between A, B, C, and so on. So it's got to be some sort of general transformation to get from t to 40 minus t. And hopefully, like at some point playing around with it, you can figure that out. If not, then take that on board. That's the sort of thing that's being asked in this question. Now, this is an extension now. We don't need to do this bit that all the question asked was to show that that was true. But it's worth now just bearing in mind, back to this formula. Actually, I'm going to rewrite it. It's going to be T is going to be A plus D plus G over 3 plus 15. So the smallest T is going to be when A plus D plus G are 1, 2, and 3. So it would be 6 over 3 plus 15, which is 17. So that 17 was actually the smallest. And then the largest is going to be when we use 9, 8, and 7. So I was just doubting myself there. So I'm going to get 24. Okay, so in fact, this is quite a nice thing to show that t has to be between 17 and 23. Actually, this is an alternative way of doing the whole problem. We've shown that 17 and 23 are possible, although I kind of used my result to get 23 from 17, but you could do it independently, and then you would show that if 17 is, well, 17 is possible and 23 is, so that would satisfy it. But now we know that 20 works, but it's then just the other ones. What about if t is equal to 18? Is that possible? So if t is equal to 18, then it would be a plus d plus g is equal to 9. And so then you can look at some possibilities. So 1 plus 2 plus 6, for example, that would and these are, you can swap these around, like a, it doesn't matter that g is 6 or a is 6 or whatever, but that would be some that you could try and put into the corners. 2 plus 3 plus 4. Or actually, I've missed out. I should have been a bit more systematic. 1 plus 3 plus 5. And actually, it's possible to show that this is not going to be possible. So let's just try it out. 1, 2, and 6, for example. Then our total leftover will be 45 minus 9, which is 36. So these two add to 7, these to 3, and these to 4. Now, it is possible to show that this is, I'm not going to do the whole thing now, but, not possible. Okay, you have to make a good argument for it, and then you'd have to do the same for 2, 3, 4, and 1, 3, 5. So this method is a lot, takes a lot more, but basically we can't do t equals 18. And you can do a similar thing for t equals 22 and see that these are not correct. So far, like in this alternative method, we've obtained 17 and 23. So if 17 is possible, so is 23. I haven't done the whole thing, but 18 is not possible and 22 is not. 20 is possible from the start, and that's 14 minus 20 as well. So it just takes us to t equals 21. And it is possible to show that that one is true and that 19 is true. So 17, 19, 20, 21, and 23 are all possible. They're the only ones, and they satisfy t and 40 minus t. Okay, I'm sorry, I've only outlined this proof because I didn't actually do it that way. By far the best way is to realize this transformation, but it is, it goes to show, like if you thought I would never have thought of that, then at least you can see although time consuming, like an alternative way of doing this problem. Anyway, hope you're happy with that and well done on this question.